Yeah, I guess the creative challenges that we faced at Pixar were really fascinating because they're not just creative challenges, they're technical ones, right? And one of the big things that I learned while working there was really there are so many sources of challenging mathematical and engineering problems that the end users are facing that there's no reason for us in academia to just invent them. Right? I mean, you see so many people that are writing papers where essentially what they do is they just come up with a problem and they come up with a solution and then they write a paper about it and it goes to die at some academic conference, right? What I would say, what I learned at working at Pixar and some other organizations and some of the industrial collaborators we have now, Adobe, Ford, what have you, is that these folks are facing really serious challenges, and it's not just a question of hiring more coders, right? These things are mathematically difficult, and it's really our role at MIT to come up with sort of what are the underlying fundamental challenges that are sitting underneath these giant systems, and can we isolate those, work really hard for people to understand them and eventually solve them, and then maybe we're not the guys that are writing the code that's going to go into the final piece of software that you sell, but we can at least help you in some capacity to prototype and eventually incorporate these new ideas back into your pipeline. Right? And so we are involved in every single stage there, from the inception to boiling down something to its essence to the end, whether that's taking like an artist's painting of a scene, understanding that really what they're trying to express is a particular flow or geometric concept, coming up with the software and the algorithms for implementing that, and bringing that back into the pipeline in a way that they don't have to understand all of that math to use it at home. My group is expanding quite a bit. So we at MIT, our group consists of myself, PhD students, master's students, and postdocs primarily. We occasionally also have some engineers and scientists that visit from other institutions. So currently our group is by the fall of 2017, we'll have 10 people in our group, which is pretty sizable, right? And it's part of the reason why I reach out to organizations like ILP to help me identify people that can work with all these folks. Right, so at any given time, I would say this large group has different projects with different, collaborations, both within MIT and outside of it, assigned to them, right? So I don't think I've ever had a single authored research paper, right? All of my students are encouraged to work together with each other to get outside input, to get input from me, and it's really the interactive process that creates research in our group. Some people from industry actually came and sat in our class, as well as people from a lot of different departments. And all of the materials are online. That includes YouTube videos of all of the lectures, the assignments, slides, notes, everything. I try to run an open research group, so basically any material that we generate, whether it's for teaching or research, gets shared publicly. Like, I don't see any reason to try and mark our territory. What's really exciting is get as much input from the outside as possible. So a nice example of that is in teaching. So this past semester I taught a course that was titled Shape Analysis. And this was a really exciting class that started with the fundamentals of differential geometry and then worked all the way up to large-scale algorithms for processing big data sets of 3D shapes. Right? And so the students were exposed from geometry in the small, right? How can I use curvature and bending and edges and so on, all these kind of low-level features to design engineering tools for problems like, meshing, parameterization, all the way up to this very large-scale kind of inference learning problems that are a little less well-defined, but maybe structure arises as you have a big data set of things that have some properties in common that you're trying to parcel out. And so this was a fun class. We had students with projects in a really diverse set of areas. I had an architecture student that was coming up with software for kind of automatically designing the shapes of buildings, a medical imaging student who is comparing different metrics for the accuracy of segmenting heart data from just scans of people's internals, to computer graphics students that were making animation software. And seeing all of these students collaborate and work together was really exciting, and in fact led to research in my group. So we just submitted a machine learning paper that comes from research from a student that took my class in geometry, and now he applied it to his research in the kind of Internet of Things machine learning world. And that was really exciting for me to see that sort of the interaction of research, teaching, and collaboration, I think is really what makes this place special, and you see that happen in practice. It's not just some high level thing people talk about.